Again, like our previous two rock types, to distinguish the differences between metamorphic rocks is going to come down to the texture. And we have two main types of texture. One is what we call foliated, which means mineral alignment, or in one case when you have banding, and the other is non-foliated. You have two types of metamorphosis. Regional, which means metamorphism over a large area, typically associated with mountain building, and contact metamorphism, which is essentially where you have igneous rocks come in contact with the surrounding rocks and metamorphosize those surrounding rocks due to the heat coming from the igneous rock. Now, when pressure is applied to a rock, the minerals will line up, or like minerals with the same density or composition will line up in an orderly fashion. This is how you get mineral alignment or foliation in a metamorphic rock. And again, the grain size are going to vary. They're going to go from fine to medium to coarse. The composition of the metamorphic rock is going to have some variation of mica, quartz, feldspar, amphibole, garnet, and pyroxene. Now the last three columns of this reference table tells you some of the comments of each of these metamorphic rocks, the actual rock name, and the map symbol. So let's look at a few examples. The first one here we have is slate. And underneath the comments it says it's low-grade metamorphism of shale. And we know shale is our sedimentary. Essentially, this slate looks like a squeezed or squashed version of shale. And if you look closely, you have what appears to be layers. Now again, with metamorphic rocks, we don't say that they have layers. We say that we have mineral alignment. Okay, so here we have mineral alignment or foliation. Now here we have schist. And if you look carefully, you can see that it's sparkling underneath my light. Now, the reason why it sparkles, it has what we call platy mica crystals. Alright, so they're visible from metamorphism of clay or feldspars. So at some point, the mica crystals was clay, and through great heat and pressure, you get platy mica crystals, which tend to shine underneath light. And again, this one exhibits foliation. It may be hard to see, but it does have mineral alignment. Our third example is gneiss. The G is silent. So gneiss is a high-grade metamorphism of schist. Now some mica crystals change to feldspar and is segregated by mineral type into bands. If you look closely of this example of gneiss, you can actually see the alternating bands of light and dark. See, it's light, dark, light, dark, light, dark, so on and so forth. So this is an example of a metamorphic rocks that's exhibiting banding, where you have tight mineral alignment. Our second example of metamorphic rocks are non-foliated metamorphic rocks. These metamorphic rocks do not exhibit any type of mineral alignment or banding. And just like our previous examples, the texture or the grain size can be fine to coarse, or just coarse. The composition tends to be one mineral or just a few combination of the non-foliated metamorphic rocks tend to be formed by contact metamorphism or regional metamorphism. And we have four main examples. Cornfels, which underneath the comment states various rocks changed by heat from nearby magma or lava. Again, that's our example of contact metamorphism. Quartzite, metamorphism of quartz sandstone. Marble, metamorphism of limestone or dullstone. And metaconglomerate, which is basically the metamorphism of conglomerate. Here is our example of marble, and as you can see, it doesn't exhibit any type of foliation or mineral banding or mineral alignment. So essentially, the rock itself has a homogeneous appearance. So this is what we mean by non-foliated. So I hope you find this useful. And again, in terms of our three rock types, when using the reference table, all the information is there. All you have to do is just be patient and know how to read the reference tables properly. And again, as a reminder, in June, the Earth Science Regents, about 40% of the questions are based on the Earth Science reference table. So again, we need to master and know how to find information and how to read our Earth Science reference table.